this lesson, we're going to talk about two-dimensional figures. So we're going to identify and name polygons, and then we'll deal with perimeter, circumference, and area for two-dimensional figures. So let's first start off with, obviously, vocabulary. So starting with a polygon is just a closed figure whose sides are segments. A triangle, a quadrilateral, square, rectangle, those types of things. Now a circle is not considered a polygon because it doesn't have segments as its sides, it's round. Then we have two types of polygons, concave and we have convex. And so I want you to draw these pictures because it's kind of just, it's more of a visual explanation. They're a little bit difficult to see or to understand without actually seeing what's happening. So in convex, you extend all sides of the shape and none of them go on the inside. And then with concave, they do go on the inside. So the way that I remember that the concave is I think of the phrase cave in. And so see how it kind of like caves in right there in that area? So that is how I kind of keep those two clear in my own head. Then we have something that's called an n-gon, and that would be a polygon with n sides. So what happens is we get to a point where we don't have a specific name for the number of sides anymore. With 3 sides it's a triangle and 4 sides it's a quadrilateral, but once we get to something like 26, we don't have a name for that anymore. So we would just call it a 26-gon. Then we have equilateral polygon, and that's a polygon with all congruent sides. And then, on the other hand, we have equiangular polygon, which is a polygon with all congruent angles. Now, if you combine those two things with a convex polygon, then it's called a regular polygon. Okay, so it's regular if it's convex, equilateral, and equiangular. So all of those things have to happen. Then we have perimeter, which is adding up the sides of a polygon, the circumference, which is the distance around a circle, and then area, which is the number of square units needed to cover a surface. So this one's kind of cut off. I'm sorry about that. There we go. So now what we're going to do is actually talk about these number of sides. What I will do for you is print this out on a sheet of paper along with some formulas that are going to come up here in a minute. And so you don't have to write all this down. I would rather just have it all in one place for you. So these are the names of polygons that you're going to need to know. After 12, we don't have any specific names anymore. So an example, if it had 13 sides, then the name would be a 13-gon. So that's just how you name it. There's nothing else that you can call it after that point. Okay, so we are going to name and classify polygons. So we have 3 different polygons down here. We're going to name it based on its number of sides first, and then convex versus concave, and then regular or irregular. So I'm going to go ahead and start with this first one, number of sides. So based on its number of sides, so A, number of sides, this has 4 sides. So 4 sides means it is a quadrilateral. Okay, so there's that one. Ew, that's not okay, hang on. Alright, so 4 sides makes that one a quadrilateral. Convex or concave? Well, if you look at the sides, we can extend it and none of them cave in, so this would be a convex shape. And then that's B. And then for C, regular or irregular, well, we only have 2 sets of congruent sides, so this would be irregular. Okay, so there's the classification for that information for number 1. Now when we move on to number 1B, I guess, we're going to start with naming it by its sides. Well, when we count them up, it turns out that it has 10 sides total, so 10 sides makes this a decagon. All right. Then for the second part, is it concave or is it convex? In this case, the sides cave in, so concave. Now, when we get to regular or irregular, even though all the sides are congruent and all the angles are congruent, this is considered irregular mainly and actually completely because it is concave. That is the only reason. It can't be concave and also be regular. Okay, and then for our third one right here for 1C, starting with the number of sides, there are 6. So 6 sides means that it is a hexagon. In B, when we're looking at convex or concave, when we extend the sides, they all stay on the outside. So this is convex. And then it is a convex polygon, and all the angles are marked the same. All the sides are marked the same. So this would make it a regular polygon. So there's our classifications. Now we're going to do perimeter, circumference, and area. So again, with this whole thing right here, I will print this out for you and put it on a sheet of paper. Just then I know for sure that everything stays, you know, organized and you understand what everything is asking you or giving you, you know how to label the information, that kind of stuff. So to avoid any, you know, mishaps in copying it, I'm going to give this to you in class to use. Okay, so now we're going to use these formulas. So here's our first example here. We have a rectangle, right? Some type of a quadrilateral anyway. So we're going to find the perimeter of this, and then we'll move into finding the area. So starting with perimeter, the perimeter formula is 2L plus 2W. And L is the length and W is the width. And these two are interchangeable. It doesn't matter what you use. So we get P equals 2 times 6 plus 2 times 5.5. And so your total perimeter then for this shape would be 23 feet. Okay, it's important that you include units if they are given to you. Then we move into the area. And area for a shape like this is just length times width. So we're going to take our 6, which is our length, and multiply it by our width of 5.5 to get a total area of 33 feet squared. So remember, it's always square units. Another way that you could write that is 33 square feet. You might also see that abbreviation as well. So either one of these is acceptable in how you could write your answer, but making sure that you have your units in there. All right, for this example, now we have a circle, and so we can't do perimeter for a circle, we do circumference. And the circumference of a circle is just 2 pi r, and r is the radius. But what's the radius of a circle? Well, the radius is from the center out to the side. So in this case, we actually have the diameter. So if I cut it in half into 2 congruent parts, then we have 3.1 on each end, giving us the radius is 3.1. So to get the circumference, we take 2 times pi and multiply it by our radius. And to keep it simple, you can just multiply 3.1 times 2 to get 6.2 pi centimeters. You can absolutely write your answer like that. You do not need to multiply pi out. Oh my gosh, I can't even draw a line. What's happening? There we go. So you don't even have to multiply that out, but you could, and you could use the pi button or 3.14. It's whatever works for you, and you would get 19.5 centimeters, around that anyway. So either one of those is okay with me. I would actually prefer this one just because then we don't really need a calculator. Then for the area, so our area formula is taking the radius and multiplying it by pi, so squaring the radius and multiplying it by pi. So we take pi and multiply it by our r, which is 3.1, and we square that. So our area would be 9.61 pi, and then our units, which is centimeters squared. So again, you can leave it in this form. This would be perfectly acceptable and really truly the best way so you don't have any rounding to deal with. Or if you multiplied it out, you would end up getting 30.2 centimeters squared, which is also an acceptable answer. So either one, whatever kind of suits you best. And then for our very last example, we have a triangle. And so with this triangle, we're going to start with our perimeter. So the perimeter formula is B plus C plus D. So basically just taking B, C, and D, all 3 sides, and adding them up. So we get 9.5 plus 9.5 plus 10.2. So our perimeter for this example would be a total of 29.2 centimeters. Okay, so there's that example, or answer. And then for our last little bit, doing our area. Area of a triangle is 1/2 the base times the height. Now the height is always the shape, or the segment that you see with the right angle, and the base is always where that right angle is, which in this case is on the 10.2. So we're going to take our 1/2, the base is going to be our 10.2, and our height is the 8 inches. And so then that would mean our area is 40.8 inches squared. And I just realized that I put the wrong units on the perimeter. I did centimeters, which was our last one, so let me go ahead and get rid of that. And we should actually have inches there. Sorry about that. That would be inches. Okay, so that's it. I know it's probably a lot of writing. I'm trying to save as much as I can for you and not have you do a whole lot, but at least it's a simple concept. None of it really is new, so just be ready to come in and practice.